Just start? Okay, is it been recorded? Okay. So today we are continuing again trigonometry from where we left off last time. Okay. So, but a little recap what we studied last time. We studied the formula of cosine A minus B last time, which is cosine A cosine B plus sine A sine B. Okay, it's pretty easy. Okay, how did we prove it? We proved it using unit circle. Okay, so let's suppose, okay, so we drew coordinate plane on the unit circle, and let's suppose that this angle is A. Okay, and even though I have drawn it in the second quadrant, it is true for any quadrant. Okay, it's a general formula because I'm not going to write the coordinate of this. I'm going to write the general coordinate, which is going to be cosine A cosine sine B sine A. Okay, so yeah. So this is the general, form. Wherever the angle A is, if it is in the first quadrant, second quadrant, third quadrant, or fourth quadrant, the general form of the coordinate is going to be cosine A sine A. Okay, and I'm going to draw another angle, which is, let's say, B. Coordinate of this will be cosine B or sine B. Okay, this is how we proved it. Again, this is true for any quadrant. And this here is going to be what? This angle is going to be cosine A minus B, and the code, this code is the, this code has the central angle of measurement A minus B. Does that make sense? This angle is going to be A minus B. And then we're again going to draw A minus B manually. Let's suppose this is A minus B. Okay, so we draw A minus B manually. Let's suppose this is A minus B. Okay, then the coordinate is going to be cosine A minus B, comma sine A minus B. Okay, and the code made by this central angle, okay, this code is going to be of the same length as this code because both of them have the same central angle. Okay, and if we equate, and this is going to be 1, 0. Okay, if we equate it, the length of this code and the length of this code, and do the solutions, we're going to have the formula of cosine A minus B. So that was a quick recap of that. We did it in depth in a previous video. Now the next question is, why use unit circle? Why don't you use any general circle? Okay, then the computation becomes easy if you have the unit circle. This is the only advantage of the unit circle. Okay, if you use any general other circle, then there is an extra factor here of r. Let's suppose the r is the radius. Okay, there is an extra factor r multiplied to this. To all of them multiply r. Okay, to all of them you're going to multiply r if it is other kind of circle. Okay, because the length of the radius is r. Okay, why is it going to be r multiplied by those trigonometric ratios? If you draw a triangle there and then find those ratios, then you can see r is there. When you can see r is there, and if you do the computation, then you'll understand why. Okay, so yeah, and then if you now find the length of this code, then the length of this code, do the solution, then again the r will cancel out and you're going to have the formula of cosine A minus B, but the computation becomes more heavier and more lengthy. Okay, so that's why you use mostly unit circle. Okay, but you can do it in any circle, on any circle you like. Okay, but unit circle is more handy. Okay, now if you have the formula of cosine A minus B, you can derive the formula of cosine A plus B. Okay, so we have these formulas now. Cosine A minus B was cosine A cosine B plus sine A sine B, and then you can derive the same cosine A plus B formula from this formula. This is going to be cosine A cosine B minus sine A sine B, and in the same way you can derive the formula of sine A plus B, okay, from this, and sine A plus B is going to be sine A cosine B. How are you going to derive sine A plus B? In the form of cosine. Sine A plus B is going to be cosine pi over 2 minus A plus B. If you use it now, this, let be angle A, let be angle B, okay, or maybe alpha beta if you're not comfortable with A's and B's, because A's and B's are there, don't want to use the same thing, then alpha beta. And if you apply the formula of cosine alpha minus cosine beta. Okay, do the computation, solve it, then you're going to have the formula for sine A plus B, which is going to be sine A cosine B plus cosine A sine B. Okay, in the same fashion you can do it for sine A minus B, which is going to be sine A cosine B minus cosine A sine B. Okay, so these are the formula of okay, so these are the formula that we need, okay, in this chapter. Okay, these 4 formulas of angle A plus B and A minus B. Okay, now based on this we're going to do one example problem. Okay, okay, not one, I'm going to actually give you more example problems. Okay, so let's suppose we have to find the value of cosine 15. How do you do that? Let's see who has the idea how to find the value of cosine 15. First you tell me.
Cosine 15.
15. How can we find it? Cosine 15. Okay, you tell me now. Both of you. First you. How you can find cosine 15?
A minus B के form में आने.
Okay, A minus B you can use, but tell me those angles as well. Which angle minus which angle? Tell me. Okay, it's easy. It's going to be cosine 45 minus 30. You can use this one. So it's going to be cosine 45 degree times cosine 30 degree plus sine 45 degree sine 30 degrees. Now cosine 45 will be 1 over root 2. Cosine 30 is going to be root 3 over 2 plus sine 45 is going to be 1 over root 2 times sine 30 is going to be half. Okay, solve it and you're going to have the value. Okay, so it is going to be root 3 divided by 2 root 2. Is it in the quadrant or not?
Yes.
Yes. Plus 1 over 2 root 2, and you have the value root 3 plus 1 divided by 2 root 2. Okay, so this is going to be your value for cosine 15. So cosine 15 will be root 3 plus 1 divided by 2 root 2. I can wipe out the solution now. Okay, this is how you find cosine 15. Another question: how can we find out cosine 75 degrees? Have any idea? Okay, again this is easy.
90.
Cosine, no, if you do 90 you have to subtract 15 from it. So we now know what cosine 15 is. Okay, but we have to do more computations. We have to find sine 15 as well. Okay, but better than that is this one, 45 plus 30. Okay, 90 minus 15 if you do that as well will give you the answer, but that will be more computation heavy, but this is going to be less computational. Cosine 45 cosine 30 plus, okay, so I leave on you can do it. Okay, sine 45 plus sine 30. Okay, you can do it, it's easy. So yeah, you can figure out what cosine 75 is. Can we figure out what cosine wait a minute. Okay, so this many examples are enough now. Okay, so the next example is, okay, find this out. Cosine 5 pi over 12. Okay, so which angle is that in terms of degrees? What is that going to be? 5 pi, so it's 5 times 180 divided by 12. So what is that going to be? 900 divided by 12. I don't know what's the division. Okay, it's going to be in decimal. Okay, so in degrees it is going to be this much degrees. But if you have to find out this value, let's say, how do you do this? We can do it without converting this into degrees. Are you not paying attention? You can do it in radians as well. Have any idea how you can do it? Pay attention here. Now, if we write this as 5 pi as 4 pi over 12 plus, okay, pi over 12. Okay, so let me do one thing. 5 pi over 12. 4 pi over 12 can be done easily. Okay, if you have pi over 12, what is that going to be? 180 divided by 12. Okay, so this was a little made tricky. Okay, so this is the same thing as 75 degrees. Okay, if you see it carefully, this is the same thing as 75 degrees. Divide it, then you have it. Okay, so the same thing as 75 degrees. So what are you going to do here now? 45 plus 30. Okay, so 45 plus 30 is 75. How do you write in terms of radians? What is 45 in terms of radians? Pi divided by 4. And what is that in terms of radians? 30. Pi divided by 6. Okay, if you do 5 divided by 6, we're going to have that. Okay, so we can write this as what? Cosine pi divided by 4 plus pi divided by 6. Okay, because if you do this thing is the same as 5 pi over 12, because we can write 12 here. Okay, 12 is the common denominator. It's going to be 3 pi, and this is going to be 2 pi. 3 pi plus 2 pi is the same thing as 5 pi over 2. Okay, so you can break this down into pi over 4 and pi over 6. Now the same thing as the previous one. Pi over 4 is 45 and pi over 6 is 30. Okay, so do the computation and you're going to have the value of cosine 5 pi over 12, which means this. Okay, easy one. Let's give you another example. Let me think of one example. Okay, one example I want to give it to you. Okay, so one problem that I want to give to you is this. Okay, so I won't do this one. Okay, I won't do this one. You have to do it on your own. Okay, so what is the problem? So the problem is cosine 87, okay, and cosine 90 degrees minus sine 87 sine 90 degrees. So what is this going to be? You have to find this out. Okay, 93 is here. Okay, what is this going to be? Find this on your own and I won't tell you the answer. I'll tell you the answer of this one in the next video.